5, 6, 7. Okay, so we are recording session at this time. Okay, so we're gonna learn about derivative as one of the tools, people, that help you to instead of taking the limit, we're gonna have to find a short way to take a derivative, and so you can get the answer right away. Okay, all right. First, we want to learn about what we call the power rule. And if f of x is x raised to the n, and n is any real number, okay, then the first derivative, remember the first derivative represents the slope, the tangent line, right, is n, and I should put a time there, make sure it makes my clear, x n minus 1. Okay. So again, this is the rule there that is very important to know, okay? And if you study mathematics in college, okay, you may need to prove that rule is correct, okay? Let's look at an example to clarify this understanding, okay? If f of x is the square root of, the cube root of x, okay, it also could be written as x 1 to the third, right? According to algebra 2, you should know this already, okay? Then, observe that, people. If I take the first derivative of this one, okay, what do I need to do here? Well, this is your n there, right? This is your n, right? So this n there needs to come down in the front of the x, as the following there, and then the n will be subtracted by 1, becomes negative 2/3. That's the first derivative, people. Right there. Done. Finish. Instead, taking the whole entire limit as h approaching 0 of f of x plus h minus f of x of h. Okay. Instead, what you did, you applied the simple rule, okay, to help you to find the first derivative. Again, n is 1/3. You bring that 1/3 in the front of the x, and then you subtract that 1/3 by 1. Is it clear? Okay. And now I also want to show you the notation. This is one of those notation there. F with f prime, or we also call this the first derivative. Let's look at a second example. If y equal to x pi, well, this time, what is my n? It will be what? Pi, right? See, before it was 1/3, now it's pi. It's anything to the exponent there, right? Okay? So then, dy dx, the change in y over the change in x, remember that represents the slope of the tangent line, remember that? Okay? Again, that pi goes up in the front of what? Dx, and then pi minus 1, right? In calculus, we don't go all the way through, okay? We leave things like this for now, okay? Is it clear so far? Okay. Any questions, people? Okay, let's move on. Example 3, okay? If f r, okay, the reason that shows r is because it doesn't have always has to be an x, r cubed, okay, you can write it down also d over dr. The 3 will be what? The n. The n here is 3, so 3 goes in the front of the r, and 3 minus 1, but 3 minus 1 becomes 2, so this is your first derivative. Okay. I want you to pay special attention to the notation, especially, okay, in calculus, because some of you will take calculus in college, and it depends on the book you're getting. Different authors have different notation, okay? So that's one of them. That's the most common one, okay, this one. You also have this one, which is another common one, okay, dy dx, because this is very obvious. Oh, it looks like the slope to me here, right? Okay. And this one too, another common one, d over dr. Okay. So why don't you guys go ahead and do this one for me, please, and try to get to the answer there. So do example 4 to see if you can get to this answer right there. Soon you should be able to do this on the top of your mind, okay? Okay, so what is my n? 4. The 4 goes on the front of what? The t, and 4 minus 1 is 3. There we go. Now look at the notation. dy dt, the change in y with the change in t. Done. Okay, people. The reason I give you plenty of time to do your homework there is because you got plenty of those, okay? To practice those. So I will make sure you're on the right track in this area. It's not bad so far, right? It's just a little bit of arithmetic involved in there. Okay, so let's look at the next page. I don't want to do example 5 yet, okay? I just want to look at the rules so far, okay? I'm going to come back to this one later. So let's look at if you have a case that looks something like this. Okay, maybe I should put a piece of paper over here. Okay. In this case there, you realize what? Well, this time the exponents, it is at the bottom there. You see this? Right there. Okay. Instead to leave it at the bottom, you want to raise this exponent to the top. So it's t raised to the -9. Can we do that? Yes. Okay. Well, right now you realize what? Oh, my -9 is my n. This is my n right there. So my n goes on the front of the t. And -9 minus 1, according to the power rule, gives you -10. Okay? Now, in purpose there, I wrote this into 2 different notation. The first derivative, s, you see this? Is also equal to the change in x over the change in t. But also we wrote this form into what? -9 and t above this to the bottom becomes 10. Okay, you don't got the idea, people? Okay, so I wrote into 2 different notation to show it to you. Okay, are we okay so far? Okay, all right. Okay, let's do another example there. Okay. With another notation too. So let y go to of x equal to x of e, and e, remember, is representing a number in this case, okay? And then again, n will be your e, and n goes in the front of the x, and e minus 1. But notation has changed a little bit. A different notation. This is not very common, this notation, people. This is an old notation that we used back in the 50s, okay? Alright, 50s, maybe 40s, okay? Maybe earlier, okay? But most people nowadays, when they study calculus, you kind of see this notation a lot more, but I just want to give it to you in case you see this someday. It's like, hey, what the heck is this? Or you realize, hey, it's kind of an uncommon notation, okay? But it's there. If you see some old calculus books, you will see this again. Okay. Another question there. Does the power rule for y equal to e of x? What do you think? Well, this question there is a very common question there because people, I mean, there's two different examples there. Okay, this one here is x to the e. Okay, but this is the reverse of this is e to the x, and you see this before, people, right? It looks something like what? Can somebody help me out? Exponents, something like this. It passes to what? 1 and goes something like this, right? Shoots up like this, right? It should be more steep, but here we go. Okay. It is a function, people. So we say no. Okay, no, y of x, okay, e of x is not a power function, but actually an exponential function. Okay, so let's be aware of the following. So, see, y e of x. Now, like everything, people, there is some rules, okay? All right, there is rules everywhere, okay? And we don't need to write this one down this time because I will give you copies of my notes later, okay? But like everything, there is rules to apply. Remember the limits rules we applied this year? When you add, you subtract, you multiply, and you divide, right? Okay, so show it to you, okay? But it's kind of ugly, okay? I'll show you a portion of it, okay? There's a lot of what? Rules, okay? When you have an exponent, when you add them together, when you subtract them, there, okay? And I made a mistake here. It's not supposed to be a plus, it's supposed to be a minus. I think I changed the last year. Okay, much better, okay? And when you have a product, okay, like this, and when you divide, okay? So in this time, people, we're only focusing today, on Tuesday, we're focusing more on things like the power rule. We're going to be focusing on this today too, a little bit more. And then on Thursday, Friday, I'm going to focus on the product and quotient rule, okay? Because I like to have you, that you have this on the front of you, okay? All right. Any questions so far? Are we okay? So the next session here on Thursday, we're going to do an example there, 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 and hopefully we can do an example on Friday on the product and this quotient rule back there, okay? Now there. Those are the two hardest ones, the bottom one, because you had to do multiple stages, get some stuff done. Okay? All right.